Welcome to springlib.
So we have a rope, and we have a ball swinging on that rope vertically. And it gets to a certain point where it's 36.9 degrees past the vertical, 36.9 degrees. Okay? And at that point, you've got your ball here. And they want us to kind of just draw a diagram here to describe what's going on in this situation. All right. So we have this 1.5 meter rope. I have a other angle here, which I can describe here. That's 53.1, judging by the 36.9 given. And then we have the acceleration vectors given to us in the question, and the components rather, and we'll get those all pointing in the right direction. Our a sub y, of course, the main acceleration, centripetal acceleration, always pointing toward the center of the circle, points right here. So you can imagine your y will point upward, and your x acceleration will point leftward there. And the ball, if it were to make a full circle, you could see it's making some sort of loop, kind of like that illustrated there in that semicircle. So the acceleration will point radially inward. Let's go ahead and just label the name of these components here. So a sub y is going to be 20.2 meters per second. And just because my a sub y looks a little bit messed up from my little dotted circle, I'm going to rewrite a sub y right here, a sub y. And then you have the a sub x down here. And that guy is equal to 22.5 meters per second squared. Cool. So both of those components help and aid in fully describing the direction of that centripetal acceleration vector pointing toward the inward of the circle there. Now we want to be able to find the radial acceleration. So we want to sum the components of a sub x and a sub y along the rope. So we're going to do that real quick. We'll do that right here. And this is now for part B of the question here. So I'm going to go ahead and actually label that for part A. We'll go into part B. And the a sub centripetal equals to 22.5 for the x, cosine, because we're talking about the x, so cosine of 53.1. And plus, this time 20.2, because now we're talking about the y, times sine of the same angle. All right, and if you go ahead and you were to compute this, you're going to get the magnitude of the centripetal acceleration, and that's equal to 29.7 meters per second squared. All right, and now in part C, we want to find the speed of the ball at the instant that's being described in the figure. And so we're going to go ahead and use our relation here that relates the velocity and the radius to the acceleration, the centripetal acceleration. And we can solve this for v. And go ahead and plug in what you know here. So our v will be equal to 29.7 times the 1.5 for that radius. And don't forget your root. And then once you go ahead and crunch out that root, we're looking at 6.67 as the velocity. 6.67 meters per second.